in unsupervised way of learning. Means there are two ways in data science, in machine learning, we kind of analyze the data. One is supervised learning, where we know the kind of clusters. Means we know the data and its classes, and then we estimate something else class. So we make the model learn, we make the algorithm, we make the set of data structure that learn from the learned data, training data, and it has to perform on the experimental data. But in unsupervised learning, everything is experimental data. And whatever we get the data, then we try to find out the clusters. I mean, that's the way we think that these are the classes. If I have 5 clusters, then we expect that there are 5 clusters. So this is so. In clustering technique, we have discussed that K-mean is one of the primary technique in the clustering, where we have a fixed number of centroids, and centroids, and then we start moving the documents, the data samples, centroid to centroid, wherever it finds its minimum, and centroid then it compute itself to the cluster. Means this is a kind of we have explained. Means we'll have very soon. It is we are means it is somehow it is delaying day by day. Okay, the problem where we are dealing. So the most difficult part, that practical means through empirical way, what we are seeing is that whatever algorithm K-means we apply, the initial set of centroids, it make drastical difference. Means if I have 2 clusters and there is one outlier, and the centroid what we initialize, and it goes to the outlier, and the second one falls in between the 2 centroids, that's it. So 2 centroid, they will find themselves 2 clusters, it falls between 2 clusters. Then these 2 clusters will find the same centroid, and the unwanted centroid will go to the outlier. Means it is something that cannot be digested. So we kind of decided that we will change the initialization. Now we found that there is a initialization procedure also, that is called K-means plus plus, and K-means. So what we expected, if there are 2 clusters and there is outlier, then these 2 clusters should not go to one centroid, and outlier will have one centroid. And there are many other scenarios also. Like if I have one cluster and there is another cluster, and then if I have centroid falling here and in between, then intersection would come. There are many drawbacks of the randomly selecting the centroid at the beginning. So we are kind of wasted. For 2 days around we wasted. Just everything is correct, but it won't work. So selecting the centroid at the beginning is key issue. Based on the centroid, initial centroid, the cluster changes. So K-means plus plus, this is what we want to implement. So in K-means plus plus, they try to, the algorithm tries to kind of set the initial centroid to their maximum distance. So it will kind of spread over kind of in little equal balance way. So that is the K-means plus plus. So like we select any centroid, any point as a centroid, then we try to find out a point that is at maximum distance from the centroid. That would be the next centroid. Now we have 2 centroids, then I'll find a centroid that will be at maximum distance from the both of the centroids. So whatever the centroid we are seeing, so we calculate the distance of all the data samples from the nearest centroid, and whatever the farthest we get, so that becomes the next centroid. So suppose I have 3 clusters, and somehow I get this first cluster as a centroid. Then I'll find the maximum distance from this. So the end one we'll get a new centroid. Now from end and beginning, I'll try to find which one has, first which one has, we'll calculate the minimum distance. So all the samples with minimum, so half, here is one centroid, here is one centroid, and there is a distribution like this. Then first half will belong to this centroid, and second half will belong to this centroid. Whoever is more furthest, so it will come at the center. So we get the kind of equal distribution of the centroids in this fashion. So to distribute the centroids kind of equally all over, K-mean plus plus comes to the rescue. So if I have 4 points, so there is a rectangle and there are 4 points and width is more, height is small. Now if I pick any 4 point, as there are 2 centroids, any point as centroid, then I'll calculate the distance from it, and whatever is the furthest, that will minimum distance to this centroid, so all will have. So 2 corners will come the center. This is what we want, means the nearest to width wise we get the 2 centroid. Otherwise, if it falls in between center, then top 2 and bottom 2 will, this is what we don't want. So to distribute the centroid, the initial state is crucial. What is crucial? What is in the K-mean plus plus algorithm? So we just demonstrated that we pick one centroid, and then from that centroid we calculate every point's minimal distance. Okay. So if I have 2 centroids, then there is 1 point, then the minimum distance will be calculated. So like that, all points minimum distance centroid means cluster, their kind of hypothetical clusters will be calculated. If there are 2 centroids right now, then hypothetical 2 clusters will be selected, and whatever the distance what we see is the maximum, because that guy deserve a new centroid. Means I think there are, if I find 2 centroid, 2 clusters, 2 centroid, and try to get the distance of the variance of the kind of intra-cluster, then we get the 2 set of variances. Then we compare which one is the farthest, so that deserves a new centroid. So that is the idea of expanding the centroid. But the biggest thing in the centroid in K-mean plus plus is, suppose the situation where I have 2 clusters, 1 cluster here, 1 cluster here, and 1 point is far, that is the outlier. And first beginning cluster, we have selected one centroid. Now the farthest point will take away the second centroid. So of no use, means we kind of jump into the same well. So it is out of any use. So 1 cluster, second cluster, 2 clusters are there, 1 outlier is there. If I choose a centroid in the first cluster and then try to get the distance of all the data from this, then outlier will catch the next centroid. So here the idea is that if I say whatever distances we are getting, then we will kind of make the weighted sum of the distances. Means wherever the bunch of data is there, so that bunch of data will have accumulated distance. So if distance we calculate and there is a bunch of data, then accumulated distance is more. So it kind of just crosses the distance what one outlier would do. So another cluster would get the new centroid. 2 clusters, 1 outlier. Second clusters, the kind of the computed distance, means weighted distance. The weight of the distance of that cluster is more than the outlier. So this cluster would get the new centroid rather than the getting out. So this is the crucial thing. Generally people, they don't discuss, they don't understand. I have not seen any algorithm. They implement this thing, but just they calculate the maximum. So that will calculate, and so that the centroids, the expectation for the centroid to the cluster it should go, not to any high distance outliers. So how we calculate the weighted sum, and then how we will use kind of some kind of a probability. So if distance is more, then anyway the getting selected probability is more, but if it is in bunch, then it would add up the distance. So that will